Today begins our short study on probability. Several definitions in this section that we need to talk about. Outcomes are the most basic possible results of observations or experiments. For example, if you toss two coins, one possible outcome is heads and then tails, and another is tails and then heads. An event consists of one or more outcomes that share a property of interest. For example, if you toss two coins and count the number of heads, the outcomes, heads tail and tails heads, both represent the same event of having one head or one tail. Example 1, consider the families of two children. List all the possible outcomes for the birth order of boys and girls. If we're only interested in the total number of boys in the families, what are the possible events? So the total possible outcomes would be you could have a boy and then a boy. You could have a boy and then a girl. You could have a girl and then a boy. Or you could have a girl and then a girl, right? The events that we just want to look at boys is, well, there's the possibility that you could have no boys. There's the possibility that you could have just one boy. It's either of those situations. And there's two outcomes in which you could have one boy. There's just one outcome in which you could have no boys. And then there's the outcome where you could have two boys. The probability of an event expressed as P of the event is always between 0 and 1. And there's a reason for this, because you've got a decimal that represents a percent, and a percent will always top out at 100%. So the probability is always going to be between 0 and 100%, or as a decimal between 0 and 1. The theoretical method for probability: count the total possible outcomes. Among all the possible outcomes, count the number of ways the event of interest can occur and determine the probability. So the probability, the theoretical probability, is the number of ways an event can occur divided by the number of outcomes. There's two types of probability that we'll talk about. There's theoretical and empirical. And theoretical is just what it says it is. It's according to theory, what would the probability be? Empirical is when you do an experiment and then find the actual probability according to your experiment. Apply the theoretical probability to find the probability of getting exactly one head when you toss two coins. So you toss two coins, you could get heads and then tail. You could get tails and then heads. You could get two heads, or you could get two tails. So there's two situations where you could get exactly one head. So the probability of one head would be 2 out of the 4. Do reduce these. So the probability would be 1/2. 1 out of 2. The probability of getting a 3 when you roll a 6-sided die. Well, you could get a 1, a 2, a 3, a 4, a 5, or a 6. there's only one in those 6 in which you could get a 3. So the probability would be 1 in 6. There are 52 cards in a standard deck. There's 4 suits known as hearts, spades, diamonds, and clubs. Each suit has cards for the numbers 2 through 10, plus a jack, queen, king, and ace, for a total of 13 cards in each suit. Notice that hearts and diamonds are red, while spades and clubs are black. If you draw one card at random from a standard deck, what is the probability that it's a spade? So if 1/4 of the deck are spades, there's 13 in each suit. We're going to take the number of spades over the total number of cards. There's 13 spades out of 52 cards, and that reduces to 1/4. The probability of getting a spade is 1 to 4. And we've already talked about that a bit. Relative frequency. Well, I said empirical probability, which is the same thing as relative frequency. So, excuse me there, but it is the same thing. But we're going to call it relative frequency. A second way to determine probabilities is to approximate the probability of an event, making many observations and counting the number of times the event occurs. This is called the relative frequency method or the empirical method. So that you find it by the number of times that the event occurred divided by the total number of observations. So if you're interested only in the number of heads when tossing 2 coins, then the possible events are 0 heads, 1 head, or 2 heads. Suppose you repeat a 2-coin toss 100 times, and your results are as followed. You get no heads 22 times, you get 1 head 51 times, and 2 heads 27 times. Compare the relative frequency to the theoretical probability. So, if we look at 0 heads, 1 head, and 2 heads, the theoretical probabilities here would be the chance that you would get 1 head would be 2 in 4. Or 0.5. So the chance that you get no heads would be 1 in 4, or 0.25, and the same with the chance to get 2 heads, 0.25. Because if we look at our situations, you could have heads, 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 tails, tails, heads, tails, tails. Okay? And then the relative frequency in this particular situation said for no heads, they got 22 out of 100, which is 0.22. For 1 head, they got 51 out of 100 of the tosses, 0.51. And for 2 heads, there were 27 out of the 100, so 0.27. The relative and theoretical probabilities are different, obviously, but they're pretty close, okay? So we've really not got any reason to suspect that any of these coins are unfair. Since you've only done 100 tosses, you're not gonna get exactly the theoretical probability. But the more tosses you do, if you do 1,000,000 tosses, then you'll get closer to the theoretical probability. A theoretical probability based on the assumption that all outcomes are equally likely is determined by dividing the number of ways that it can occur by the total outcomes. We've already talked about this. The subjective probability is an estimate based on experience or intuition. Identify the method that resulted in the following statements. I'm 100% certain that you'll be happy with this car. It didn't say that that was based on any experiment or any data, so we'll say that that is subjective probability. Based on government data, the chance of dying in an automobile accident during a 1-year period is about 1 in 8,000. Well, even though this isn't an experiment, it is based on data, not on theory. So this is relative frequency. The probability of rolling a 7 with a 12-sided die is 1 in 12. That is theoretical. If the probability of an event is P of A, then the probability that it does not occur is 1 minus P of A. Now that makes sense, okay? If there's a 70% chance that it's going to storm, and I hear thunder, so that's pretty good, better chance than that. But if there's a 70% chance that it's going to storm, then there's a 30% chance that it's not, right? So you subtract from 1. A probability distribution represents the probabilities of all possible events. So you list all the possible outcomes, identify the outcomes that represent the same event, and determine the probability of each. And make a table listing each event and probability. So like this. All possible outcomes for 2 dice being rolled and added. So you could get 2 ones, and that would add to be 2. You could roll a 1 and then a 2. The sum would be 3. You could roll a 4 and then a 3. The sum would be 7. So these are all the possible outcomes. Then you can find the distribution by finding the probability for each. So for 2, what's the probability that the sum will be a 2? There's only 1 out of all 36. What's the probability that the sum will be a 3? 2 out of the 36. What's the probability that the sum will be a 6? 5 out of the 36, and so forth. Odds are the ratio of the probability that a particular event will occur to the probability that it will not occur. So the odds for an event are the probability that it will occur over the probability that it won't. And the odds against are the probability that it won't occur over the probability that it will. What are the odds for getting 2 heads and in tossing 2 coins? What are the odds against it? So the odds for would be the probability of 2 heads over the probability of not 2 heads. Well, the probability of 2 heads would be 1 in 4. So the probability of not 2 heads would be 1 minus 1/4. So it's 1/4 over 3/4, which reduces to 1/3. So the odds for are 1 to 3. The odds against will be the probability of not getting 2 heads over the probability of 2 heads. So the probability of 2 heads was 1/4, not was 1 minus 1/4. So the probability of not or against getting 2 heads is 3 to 1, just the opposite. At a horse race, the odds on Blue Moon are given as 7 to 2. If you bet $10 and Blue Moon wins, how much will you gain? So the odds of 7 to 2 means for each $2 you bet, you win 7, assuming Blue Moon wins. Okay? So if you bet $10, that's 2 times 5, then you would win 7 times 5, or $35. Okay? So you gain $35. But you also, in the case of horse races, get your $10 back. So you end up with $45 total.